Greetings folks. So today we will, in the journey of our data science, we'll go ahead and move on to the next module and get an introduction of the next module where we will look at the types of the data and the sources of the data and the data quality changes and issues, guys, okay? Having said that, to start with, what is data? Well, we have two kinds of data. One is qualitative data and one is quantitative data. Qualitative data, if you take an ice cream, in an ice cream you may have a vanilla, you may have a strawberry, you may have a butterscotch and things like that, guys, okay? So what we are doing is we are talking about the description. We're describing about the ice cream. That is what is called qualitative data, guys, okay? It is descriptive in nature. It describes an attribute that can be observed but not measured. We know it is strawberry or we know an ice cream is butterscotch. We will not necessarily measure it, but we are able to describe it. That is an example of a qualitative data, guys, okay? Similarly, we also have hair color, the black, blonde, brown and so on, and profession type, the engineers, tailors, consultants and things like that. That is what is an example of qualitative data, guys, okay? And then we have quantitative data. What is quantitative? Something which we can measure, which is numeric and which is measurable, can be thought of as quantitative data. It captures the measure of an attribute and, for example, height of the students, they're all measurable. Similarly, the cost and age, these are the examples of the quantitative data, guys, okay? Moving on, the basis on which we are categorizing the data. There are multiple types or multiple ways of categorizing the data. One of them is based on the type of the data. Another one is how we process them, how do we form it, and how based on the source of generation of the data, based on the size of the data, we can categorize it. So let's dig deep into these forms of categorization. So at a high level, when we are talking about the types of the data, we've just looked at quantitative and qualitative. The categorical variables are again similar to the qualitative, where if you take the binary, we have binary, nominal, ordinal, and ratio and interval. Similarly, quantitative, as we just discussed, they are numbers and things like that, guys. So let's dig a little bit deeper into this thing. Well, here is an example of a binary data. You toss a coin, we know it's either heads or tails, and a true or a false or a 0 or 1. These are examples of binary data, guys. In binary data, generally we're looking at two options. They're either true or false and things like that. So toss of a coin, switch on or switch off, dot and dash of a telegraph, again, is kind of a example of binary data. Moving on, nominal data. It is categorical data. Categorical in the sense something which we can categorize is what it can. So if you take a library, a group of books could be categorized as romance, a group of books could be categorized as humor, religion and things like that, okay? So that is what we mean by categorical data. It is coded. We're giving some kind of code and we're referring at a bunch of books as romantic and things like that. That's what we mean by they're coded. And they're representing a label, guys, okay? You can only count but cannot order or measure nominal data. It is meaningful for us to go ahead and say that a group of books are romance, humor and religion, but it is not very meaningful for us to say that they have to be in certain order and things like that. So that is what is an example of a nominal data. So names of cars, book titles in library, marital status. Again, if you take married or unmarried, you could either refer to it as unmarried and married also. The order does not really, is not meaningful there, but more of a category is what is more meaningful. That is an example of nominal data, guys, okay? Having said that, moving on, ordinal data. Here the data is ordered. So if you look at our screen here, what we have is, we have all the list of gold medals that various countries have got, and if you notice, data is ordered. If you notice, Russia is the first one and they have about 13 golds, okay? We have gold here, we have silver, we have bronze, and we have the another type of medal. And if you notice a little bit close, all the gold medals are sorted in a descending order. So that is what we mean by data is ordered, and it has a natural hierarchy. Naturally, because Russia has a more number of golds, we have put it in as the leader, and that's what we mean by a hierarchy. The intervals between the ranks may not be necessarily equal. So Russia may have got 13 golds followed by Norway, but in real world Norway could have got 12 or maybe 10, and maybe it has the second highest number of gold medals So that interval, it's not necessary to maintain the interval, guys. Okay, so that is an example of ordinal data. Moving on, then we have discrete and continuous data. Okay, so what is discrete data? Well, it is numerical data, but we have finite number of possible values there. Okay, so for example, if you take a number of people inside a room, or number of items in a basket, or number of hours in a day, they are finite and we can count them, right? So they are referred as discrete. Continuous, it's something which is continuous, as the name suggests, and they're numerical. There can be infinite number of values, guys. Okay, so ideally and usually it is in decimals, and if you were to take the heights of all the people, it can have any values, right? The weights could also range from anything to anything. The sales could be, you know, very low, very high, and account balances could be a 0 or a very, very high value. So that is what we are calling as continuous. They tend to have the continuous numbers. They may be in decimals also, guys. Okay, so that's a little bit about the discrete and the continuous data. Then we have what is called raw data, guys. Okay, and what we are doing here is we're trying to get familiar with some of the main terms that are generally used in the data science world and analytics world, is what we are trying to just a quick reminder as to why we are going through all these things, guys. Okay, having said that, raw data, what is raw data? Well, some data which we are actually connecting from the source. The source may be Twitter, Facebook, or maybe another social networking site in which we are interested. We want to get the data, we want to perform some sentimental analysis, and we want to understand the trends and things like that. So we go to an original source and we get the data, and that data is generally referred as raw data. That data could be structured, it could be semi-structured, or it could be unstructured. Okay? The very point where we are getting the data is what the source is, and that is what is referred as raw data. And sometimes, or many times, raw data has errors. It may not be validated. It may have unformatted errors and dubious or requiring confirmations, guys. So many times when we download all the text from the multiple websites and things like that, it's not validated and it's not clean. We have to extract it. We have to clean the data, and then we are able to extract the data. And then once we extract some data, we clean it, we do some transformations, that is ready to be processed and performed, and ready to do some advanced analytics like machine learning and things like that on that kind of data, guys. That is generally what happens. You get the raw data. So your raw data is like the oil in the you can kind of think of it as a crude oil in the world, guys. Okay, and generally what happens is we have a lot of crude oil in the world. And once we take the crude oil, we try to refine it and get some petrol out of that. And the petrol is what we use in our vehicles and things like that. So raw data is like the crude oil in the world, and what we try to get is the petrol, which is nothing but the insights that we try to get the raw data, guys. Okay, so here is another example of raw data. The correct format is not specified in an application format. So imagine a survey has taken place, and in the survey a few people went out and they have collected some data, and one of the fields happens to be maybe a date of birth. What are they doing? Well, some of them are entering as 31st January 1990, and some of them are entering it in the form of 31/1/1990, and so on. So this is all raw data. As they collect it without any standard procedure, whatever they collect, that is referred as the raw data. But if we try to plug this into an application may not necessarily accept that different forms of data. It may try to standardize it. That is what we mean by cleaning and transforming the data into a certain format, guys. Okay, so that's a quick touch of raw data. And then we have process data. Once we get the raw data, once you have the crude oil, we try to process it and we get the result, that is the process data, guys. Okay, so data after processing for issues in the raw data, and analysis ready data. So once you process the raw data, the data that you get, the process data that we get, is what we refer it as process data. That is ready for analysis, guys. That is what we are referring as analysis ready data. And then we have processing include. So what is the processing we do? We may go ahead and scrub it, we may go ahead and clean it, which means we're trying to remove unwanted attributes, unwanted values, and we are probably trying to get a particular structure. Where you have plain text and you want to get out of the plain text, you want to understand what is the city, what is the state, and what is latitude, longitude, and things like that. So you try to get a structure out of that, guys. Okay, we also have merging, formatting. So in other words, you may have multiple sources where you are trying to get certain text, and you want to merge them into and form a structure. So that is what we mean by merging and transforming. and all data processing steps are documented. Generally, there are certain standards and method and procedure for us to go ahead and get a certain format. So here's a quick example: recoding. Number of children filled in a survey may be left blank. Again, imagine a survey was done, and some of the people, when they went ahead and the surveying different families, they have some of them have noted maybe a 0 for those of people who don't have children, and some people may have left blank. And when this data is again entered in an application, at the time of entering the number of children, if you leave a blank, the application may go ahead and plug in a -9999, something like that, kind of null value or a very large number, and that needs to be taken care of. We cannot actually put -9999 as a number of children and things like that. It either needs to be a 0 or maybe a standard process needs to be followed there. And deriving end of day sale amount for a store. So a lot of transactions are happening in a store, and you want to understand what are the total sales made. So you want to sum up all the transactions, you want to go ahead and do some calculations, get an average, get a variation, and compare the standard deviation and things like that. So what we are doing is we are processing the data, and we are trying to get an idea of what is the average and what is the variation that is in our sales data and things like that, guys. That's an example of a process data. There are different ways in which we can collect the data. One is census. Census is generally going ahead and conducting surveys and collecting the data. It's a systematic collection of data about all the members of the population. So many times you might come across people coming over to your house trying to ask how many people are living in your family, and trying to get a picture of the population and things like that, guys. Observational study, collection of data to draw inference of outcome of a treatment on subject. It is not in control of the investigator, guys. So earlier I was trying to explain, a group of people will be selected for some clinical trials, and they want to go ahead and perform some tests on that. Once the tests are performed, they want to infer something. They want to understand what is happening. It is working on a certain group of people versus it is not working on a certain group of people. So that is what is an observational study example, guys. They are performing a test, they are trying to get the results. Based on the results, they are trying to understand and observe something. That is, again, is what is the observational study. And generally, when this kind of environment, those are referred as a control groups, is what it is, guys. Okay. Then you have the convenience sample. It's collection of data from a sample where the subjects are selected because of their convenient accessibility and proximity to the researcher. So imagine we have come up with a mobile application, and let's say you want to see what people are thinking about it. So you happen to ask some of your friends to maybe go to a mall and go ahead and give out a mobile app free for those of the people who are entering the mall. And one of your friends, what he does is he goes ahead and whoever enters the mall, he approaches everyone and just says, hey, can you please download this mobile app? We're giving it for free, and there are some benefits out of that and things like that. So what that person is doing is he's doing what is convenient to him. But what could be the actual point? The actual point is that particular mobile application is probably more useful for maybe teenagers or the mid-age people, the older age people, or maybe there are other kinds of people. It may not be necessarily applicable. But what is happening, whatever is convenient, what is convenient? Well, anybody who's entering into the mall and approaching them is convenient. So that particular person is going ahead and collecting the data from everybody based on his convenience. That's an example of convenience sample, guys. Okay. Then we have randomized trial. It's a collection of data to draw inference of outcome of a treatment on subjects, and the investigator randomly allocates the subjects to either the test or the control group. In other words, you're randomly selecting someone, and that is what is precisely randomized trial. You don't have any basis on which you are selecting, but you randomly go ahead and select somebody and you perform your test or trials on them, guys. That is an example of a randomized trial. So moving on, forms of data, we have structured data. So what we are looking at is a table of tabular data of student. We have the first name, last name, and things like that. Traditionally, whenever we're working with databases and things like that, the data, the tables are already built. We design the tables, we come up with an entity relationship model, and we understand what is the parent, what is the child, what is relationships, the constraints, and things like that, guys. Okay, so that is referred as the schema. When you know the schema of your data, that is what is called as structured data, guys. Okay, and it is well organized, it is well structured, and it might include some complex elements. So traditionally in a database world, when you have some complex structures, that's where we build the relationships, the foreign keys, the child tables, and the other kinds of tables. Okay, and relationships are well defined. That's an example of a structured data, guys. Okay, then we have unstructured data. Any data which does not have a structure is generally referred as unstructured data, guys. Okay, unstructured data could be your text in a resume, or you have a bunch of documents in your company and they all together form your unstructured data. If you just take that, you do not know what is in the data name, the column name, the data type, or the relationship about the text, that is, you do not know the schema of that. That is what is called as the unstructured. It is in an arbitrary manner, and it could be images, the binary data and things like that, resume text of a student. Coming to the semi-structured data, if you have an idea about the XML data or the JSON data, there is some attributes, there is something like a parent-child attributes and things like that. That's an example of a semi-structured data. We can understand by looking at it that there is some structure to it, and it cannot be processed as effectively as structured data, because in a structured data we tend to have a little bit of more information about the schema. In a semi-structured data, we do have an idea about the structure and certain attributes, but it is not as much as available in a structured data. And XML again is an example of a semi-structured data, guys. Okay. Moving on, then we have the batch data and the real-time processing. Batch processing is, imagine a bank, and in the banks, imagine every 2 weeks, 3 weeks, they are going ahead and running a few reports, and these reports come back and tell who are the top 10 customers, who are the customers who are happy, who are the customers who are unhappy. So what happens here is they wait for a period of time, and then they collect the data of maybe their entire database, or maybe for the past 5 years, 10 years, they go ahead and perform some advanced analytics where they try to understand the similarities of different customers. So who are the customers who might be happy? Based on a certain characteristics, you may also want to categorize another group of customers who are happy in a similar way. And what we are doing is we're waiting for a period of time, we're dealing with large amounts of data, and we are performing the processing. So that is what is an example of a batch processing, guys. Okay, it is collected, data is collected in a batch, and at periodic intervals, every 2 weeks, every 3 weeks, we tend to run some reports. That is what happens in a batch processing. There is a delay, we are waiting for a certain period of time, and the periodicity is maintained in data collection. So that is an example of a batch processing. Then we have what is called real-time processing. Data is collected in real time. Okay, so imagine you go to a store, you purchase an item, you swipe a card. What happens? Well, immediately we need to know whether there is a balance in our account or not. We can't wait for a minute or 10 minutes or 100 minutes for us to wait if there is balance or not, because we're making a purchase. That is happening at that point of time. That is called real-time processing, guys. Okay, so data is collected in real time. When I swipe my card, the transaction data is collected in real time, and it is validated, and it needs to be delivered right away. So we need to know whether there is balance, enough balance or not, and there is no delay. Delay is unacceptable, because we can that is the nature of the style or the nature of the transaction that we are involved, guys. Okay, so that is an example of a real-time processing. Then we have sources of data, where today there is a lot of data which is getting generated, and some of the data may be coming from blogs. Some people are posting some very useful insights and things like that, where they are talking some good things about a particular product, and maybe they are unhappy about a product and they're blogging about it, right? So many times companies are interested in understanding the sentiments, of the people, of the customers, whether they are happy, whether they are unhappy, or what are the trends which are going on in the market and things like that. So in such cases, we go to different kinds of websites, blogs, and sites such as Twitters and Facebooks, and we try to understand, we try to process and understand the sentiment and the trends, guys. Okay, we may also want to process the documents within our own company. There might be 1 million documents in your own company. You want to understand if a particular project ID is being referred around in any of the documents in the past few years and things like that, so that you get an idea. A particular requirement has been referred in which projects and things like that. Then you have the system or the application generated data. If I step back a little bit and I talk about user generated data is something where it is entered by the user, guys. It is something. When you get onto a Facebook or Twitter, we are entering the data. That is, user is generating the data. That is what is user generated data. Then we have what is called machine generated data. What is machine generated data? As we are accessing a particular website, behind the scenes, our IP address, the resource that we are requesting, the date, the time, and many other attributes are being captured by the servers. They're logging all this into logs and things like that. That is being generated by the machine servers, or that is what is system generated data or the machine generated data, guys. Okay, and then you have the network event logs, which is where all the logging goes in. Then we have the device generated. Today, a lot of talk is being done on IoT and things like that. They're all nothing but the sensors, the smart sensors and things like that. Every millisecond, they generate hundreds and hundreds of rows, which cannot be necessarily saved in a database because it tends to get the capacity tends to grow exponentially, and the cost of it, the complexity of it also increases. So that is a scenario of big data where tools such as Hadoop and things like that come in, guys. Okay, so these sensors, they generate a lot of data. That data needs to be saved, and that is what is the device generated data. Surveillance surveillance cameras is one example. Point of sale POS systems are generating a lot of information or data is another example. Then we have the internal data. Internal data is, you take a company will have many applications within the company, and they may have a HR application, they may have a finance application or another CRM application. All these applications may maintain their data in a database or internally on their servers. That is the internal data, guys. So any data which is internal to an organization is referred as the internal data. Then we have external data, which is nothing but which is getting generated by or which is data which is coming from the external parties. Let's say you're applying for a credit card, then there's a credit card company, and the credit card company likes to know if a particular customer has a good credit or bad credit. What would they do? They will go to a credit bureau and they will try to get some data and understand if the customer is capable of paying the loan or not based on the credit history. So they go to a credit bureau and they're borrowing some data, they're getting some data. That's an example of a external data, guys. So these are these different sources of data that we are looking at in getting the data and storing it and processing, guys. Okay, so we'll again continue in the next module. That's an introduction of types of data today, and we will continue in the next module. So please stay tuned, and thank you, guys.